For most of human history, our species has traded, fished, and traveled over the ocean. Many cultures base their entire lifestyle around it, without any knowledge of the hidden world beneath the surface. But in the past 50 years, our understanding of the depths has grown exponentially. We now know more about the deep sea than ever before, and every innovation brings with it nearly limitless potential. But what strange creatures lurk in the depths? How do we study them? Do we harm the deep sea more than we think, in turn destroying that potential?
In the old days, they used to think that nothing lived in the deep sea. They thought it was a desert with no life.
Modern deep-sea exploration based on science is said to have begun in the 1700s when Pierre-Simon Laplace calculated the depth of the Atlantic Ocean by observing the tidal motions and patterns along the shore. He had estimated the average depth to be 13,000 feet, which has proven to be accurate.
In the early 1800s, a string of expeditions to measure the depth of the ocean occurred.
Thin ropes with a lead weight, called a plummet, at the bottom were dropped off ships to estimate the depth of the water. Both the depth and sediment information were used so that the ship could navigate properly.
In the 1870s, the British laboratory ship, the HMS Challenger, went on a 4-year expedition that traveled a total distance of 70,000 nautical miles, or 130,000 kilometers. This trip laid the foundations of our current knowledge of the deep sea, and very little was known about it before the expedition. When the Challenger went into deeper parts of the ocean, 5,000 new species were discovered. When exploring the oceans, we never imagined just how deep they could be.
In 1951, a routine research mission led to the discovery of the deepest point of the Mariana Trench. Its depth was a low we had never dreamed of, 7 miles, so deep that 25 Empire State Buildings stacked on top of each other could fit inside of it.
That spot was called Challenger Deep after its discovering vessel, the HMS Challenger. The Mariana Trench is east of the Mariana Island, near the coast of Japan. In 1995, the first unmanned craft was launched into the Mariana Trench by Japan. This trench is 2,542 kilometers long and 69 kilometers wide. The HMS Challenger carried out a series of sounding surveys providing the most comprehensive view of the deep sea floor to date. Sound traveled 3 times faster in the water than on land, which is why sonar instruments are used to measure these great depths.
The organisms at the bottom of the sea have to deal with more extreme conditions than you can imagine. First of all, the darkness is pretty much impossible to deal with. We wouldn't be able to see down there. Some organisms cope with it by having huge eyes to see the almost non-existent amount of light down there. Others don't have eyes, or they don't use them, and sense where things are using vibrations instead of sight. Some very interesting organisms use light they produce to find prey. To keep buoyancy, some fish weigh very little, often with long tails to stabilize themselves. Heavier animals sink if they stop swimming. Currents are tough to deal with, and there are deep ocean currents that circle water all over the planet. Organisms have to adapt to be able to swim with and against the current. Finding food is very tough on the floor, and there are not many plants that can grow down there. Most creatures wait until food falls from above, often called marine snow. They can also feed on whale and dolphin carcasses that fall from above. Most deep ocean temperatures are very cold. Even under the warmest of the waters, the temperature hardly rises above freezing. They must have warming layers to keep them from freezing in this cold.
One of the animals that lives in the deep sea is called the Dumbo octopus. It has adapted to be able to live under extreme conditions. To cope with the pressure, its body is made up of almost all liquid. It lives down from 4,000 meters into the ocean. It is relatively small, no longer than 30 centimeters in length. In order for it to move, it shoots out water to propel itself. To conserve energy, it uses its big ears to flap and move itself around. To eat, it bounces on its prey and eats whatever it finds on the bottom of the sea, as there isn't a lot of food. It mostly eats what it finds and often goes to hydrothermal vents to find more food. The bottom of the sea is one of the most barren places on Earth, and it is amazing that anything manages to live there. Most animals survive with the help of hydrothermal vents. Large tubes send 400-degree mineral-rich water shooting out to support the diverse communities around them. These interesting features were first discovered by the same submarine that found the Titanic in 1977. But the most fascinating part about these is the ecosystems they support. Not only do organisms live without sunlight, but they thrive in these previously thought toxic environments. Special types of bacteria convert the chemicals that come out of the vents into energy, which allows an entire community to survive with complete independence from the sun. When we discovered this, scientists had to completely reevaluate their idea of life's limits. If life is possible in such hostile places, then why not on other planets?
The conditions in the deep sea are probably closer to conditions on other planets.
Our oceans cover more than 3/4 of Earth's surface and hold many of the most diverse creatures on this planet. The ocean contains miles-deep canyons, huge volcanoes, the largest mountain range on Earth, animals so alien that they do not even get energy the way we do. So why have we not explored it yet? Funding and resources often go to land research because we are familiar with what we find there. But science is all about being uncomfortable with your subject, and people have spent billions of dollars exploring space. The truth is that most people have no idea what lies beneath the surface, even though they do spend a lot of time around it.
It's an area, obviously, that is just so understudied. And we probably know more about the surface of Mars than we know about the deep sea.
I think that we should spend just as much funding on studying the deep oceans here on Earth, since there's so much that hasn't been discovered yet.